Well, good morning, everyone. And Amanda and I are going to give you a quick overview of the Footprint project that we have, hopefully funding from the state legislature for. It always has to get through the legislative process still. So, in short, we know antibiotics are getting into the environment, and classes such as fluoroquinolines and macrolides and sulfa drugs. And we know in general the pathways. They're used in agriculture, they're used for our companion animals, they're coming out of wastewater treatment plants. And we've done some preliminary work actually already looking for some of these compounds in the environment. So this is just a set of samples we took along the Minnesota and Mississippi rivers, and I haven't put a little map here. I'm assuming you know where the Minnesota River is and the Mississippi River is. So we started at the South Dakota border and go to Jordan, Minnesota, and the Minnesota River, and then started in, where did we start? We started in Grand Rapids and went all the way down to Lake Pepin in the Mississippi River. And so these are three compounds that are used predominantly in agriculture. And not surprisingly, we get the detections in the sediment in the Minnesota River. And when we started this, we thought, well, there's more people in the Mississippi River Basin. We're going to see the human antibiotics in the Mississippi River Basin. And it turns out we do, but we actually see a lot of them in the Minnesota River Basin as well. And so we can't start with assumption about where we're going to find things, because we're going to find things where we don't expect. And we're hoping that the footprint process and gathering a whole bunch of data will give us better targeting on where to go. So some of the big questions we have are, what are the impacts of these antibiotics in the environment on overall health and resistance? What impacts might they have on ecological health? And where should we target any interventions to lower the levels of antibiotics in the environment? So if we have cost constraints, of course, we want to make sure we have the most bang for the buck if we do an investment to reduce antibiotic loads. And then the big question is, how do these antibiotics in the environment affect resistance potentially in clinical or other health settings?
Okay, and the answer to that is the antibiotic resistome. So the antibiotic resistome is the collection of antibiotic resistance genes of all microorganisms, basically you could argue in the world, but in any given setting, we have a specific antibiotic resistome. And what we know is that there are bacteria everywhere. There are bacteria in the environment. And I'm going to flip through a few demonstrations here that show you how this resistome actually can impact human health. There are susceptible bacteria in the environment at any given point in time. There are also bacteria that have resistance genes. And those resistance genes can be transferred from one bacteria to another. In addition, there's also a natural drive towards the development of antibiotic resistance through the formation of mutations in individual bacteria. So we have the sharing of resistance genes, and we also have the development of resistance as bacteria replicate. Now, this is a natural process. This happens all the time. You can find antibiotic resistance genes in caves that have never been touched by humans. So we know that this is going to happen, and it's all part of this antibiotic resistome. What we also know, however, is that we have antibiotic resistance that happens in our built environments. In our environments where we have healthcare settings, where we have communities, where we have parks, we have, of course, susceptible bacteria, but we also have resistant bacteria that are sharing their genes and developing mutations in our built environments as well. The built environment, the natural environment, all of this together equals the antibiotic resistome. When we end up with antibiotics in the environment, whether it's from our medical sector and home use of antibiotics ending up in the septic, ending up in our landfills, or whether it's from agricultural use where we have antibiotics used in crop production, or we have antibiotics in manure that is spread on fields, we end up with antibiotics in the environment. These antibiotics drive the process of antibiotic resistance development in the entire antibiotic resistome. And the challenge is that because these are antibiotics that we're using in our treatment of animals, of people, that those are the antibiotics that are driving resistance. So then we see our antibiotic resistome take on the characteristics of resistance against the antibiotics that we most need. And so that's why it's important for us to understand what is the real impact of antibiotics in our environment, Where do we expect that this problem is going to be the greatest? The antibiotic resistome that we have in our built and natural environments influences how we can treat patients. It influences the susceptibility testing and the ability to use certain antibiotics for certain infections. It also influences our overall picture of antibiotic resistance when we're thinking about how is resistance changing over time, over years, over decades. So we really need to understand this better. We have a group from this collaborative of scientists who have come together to think about this problem. Particularly, what we want to do is figure out how we can be smarter about sampling the environment for antibiotics and for resistance genes. Our goal is to predict areas in the state of Minnesota that are at highest risk of contamination with antibiotics and resistance genes. So we have this team from University of Minnesota and from St. Thomas and from Minnesota Department of Health that is planning to do the following. What we would like to do is develop an antibiotic footprint of Minnesota's natural environment. The first step in this process is to create a map-based model. We want to map out across the state of Minnesota where antibiotics are used, both in human health and in animal health, where they're used in our homes for our pets, where they're used in our healthcare facilities. We will make a map of where people and animals live and where antibiotics are used. We will then use modeling to determine where those antibiotics end up in the environment. And what we'll have is a risk map or a hotspot map of where antibiotics might be in our waters and in our soils. After we have a map, we will rely on Bill and Tim LaPera at the University of Minnesota and Chris Walmer at St. Thomas University to sample our environment, to look for antibiotics and to look for resistance genes, things that they have done many times in the past. But what we have given them first is a map. It's sort of a treasure map of where to be looking for these antibiotics and these resistance genes. They'll go out into the environment, they'll collect the samples, and what we learn from that directed sampling will then improve our ability to model and to map where we expect antibiotics and resistance genes to be in the environment. So what do we need for this process? First, we need funding. As mentioned, we think that we will be able to get some funding from the state of Minnesota. This proposal has been recommended for funding through the Legislative Citizens Commission on Minnesota's Resources, so that is terrific. We also will need data. How do you make a map of where antibiotics are used? How do you know how many antibiotics are used? A lot of this is going to be based on our collaborative nature, getting data from healthcare, getting data from public health, getting data from our animal health partners, and we're going to have to put that all together. We're also going to need perhaps to get expert opinion where there are not data available. We're going to need time. It takes time to develop such a model, and it also will take time to improve that. As I said, over time, the environmental sampling will improve our model and make our mapping even better. Most importantly, we need your support. We need the support of the Minnesota One Health Antibiotic Stewardship Collaborative to take this idea that came from this group and actually make it happen. We know that we want all of the entities in this room, whether it's healthcare, animal health, animal agriculture, environmental health, to feel like this is a project that belongs to them. And it's going to give us valuable information that improves all of our fields.
Yeah, so our overall goals here is we want to be smarter about where we're doing our sampling in the environment. It's expensive to do it. So if we want to do the resistance genes and antibiotics in a single sample, you count labor and everything else, it's about $1,000. And so we can't sample everywhere. And so if we use the map to decide where to sample first, we can do it much more targeted. We can also increase our knowledge greatly about where antibiotics are used in terms of both human and animal health fields. And the big thing here is no state has done anything like this before. And so we can really be a leader in the country in developing a system like this. And also, it's a big opportunity for environment, agriculture, human, One Health, all to come together and do something that's much bigger than the whole will be bigger than the sum of the parts. Thanks.